This is an incredibly important video. We're going to be learning how to find trigonometric values from the unit circle. Quickly finding trigonometric values for different angles is something that you need to be good at. It needs to be like our multiplication facts that we can quickly pull these values. So rote memorization is an option, but I think for long-term retention, remembering this material, having a deeper understanding is much more effective. So I'm going to be teaching how to find values off of the unit circle using our two special right triangles. So to refresh your memory, with the 45, 45, 90 triangle, the two sides are the same. We label them x, and the hypotenuse is always one of the sides times the square root of 2. In a 30, 60, 90 triangle, the smallest side is across from the 30-degree angle, and we label that x. The longer side is across from the 60-degree angle, and it's the short side times the square root of 3. And the hypotenuse of our 30, 60, 90 triangle is twice the short side. We label it 2x. So I'm going to think about our special right triangles if they're inscribed in the unit circle. The unit circle, by definition, has a radius of 1. So if we look at a circle centered at the origin with a radius of 1, imagine my circle's perfect. Right, if we're putting these right triangles inside here, right, creating a perpendicular, notice that the hypotenuse of these right triangles is equal to the radius of our unit circle, which we know is 1 by definition. So I want to label the sides of these two special right triangles, assuming that the hypotenuse is equal to 1. All right, so we'll start with the 45, 45, 90. So if the hypotenuse is 1, I think about how, in my general triangle, to go from the hypotenuse to the leg. Usually we think the other direction. To go from the leg to the hypotenuse, we multiply by the square root of 2. So to go from the hypotenuse to the leg, we need to divide by the square root of 2. So if we take that 1 and divide it by the square root of 2, that should be equal to our leg. But we want to write this in a rationalized form. So we'll multiply the numerator and denominator by the square root of 2, giving us square root of 2 over 2. That is going to be the value of each of the sides of a 45, 45, 90 triangle when we're in the unit circle. This is something you want to memorize. We're going to do the similar idea with our 30, 60, 90 triangle. If the hypotenuse is 1, looking at my general form, the hypotenuse is twice the short side, so if I want to go from the hypotenuse to the short side, I need to divide by 2. 1 divided by 2 is 1/2. So the short side of our 30, 60, 90 triangle is 1/2. And then to get the long side, I think it's easiest to take the short side and multiply it by the square root of 3. So if we take 1/2 and we multiply it by the square root of 3, we get square root of 3 over 2. So the long side of our 30, 60, 90 triangle in the unit circle will be square root of 3 over 2. You want to memorize this as well. We're going to use these special right triangles to understand and find values from the unit circle. So let's start by finding sine of pi over 4. Well, the first thing we want to do is decide what this angle is in degrees so we can find the reference angle. Now, after some time, you may be able to do it with just the radian, and I'm going to point out some shortcuts to help you with the radian, but in the beginning, you may want to convert it to degrees to start. So if we take pi over 4 and multiply it by 180 over pi, we're going to get 45 degrees. So this is the same as finding sine of 45 degrees. Starting from our standard position, 45 degrees is going to be right here. We're going to drop a perpendicular to the x-axis, creating a right triangle. And in fact, this is a 45, 45, 90 triangle, so we know that each of the sides is going to be square root of 2 over 2. That's the thing I said, we got to memorize that. And I remember it because the two sides are the same, so it's all the 2's. And our hypotenuse is 1. We saw in the previous video that on the unit circle, sine is defined to just be the y value. Now, SOHCAHTOA still applies, and we could do opposite over hypotenuse. It's just a little bit more work. So we know that sine is the y value on the unit circle, which is going to be square root of 2 over 2. So sine of pi over 4 is square root of 2 over 2. Next, we want to find secant of 2 pi over 3. I'm going to start by figuring out what this degree measure is. We'll take 2 pi over 3 and multiply it by 180 over pi. So we're getting 120 degrees. So we're looking for secant of 120. That'll push us into quadrant 2. We're going to be 30 degrees past 90. And I'll drop my perpendicular. That's 120 degrees, so our reference angle is going to be 60 degrees, because that's how much more we need to get to that 180. So this is 60 degrees. This is going to be 30 degrees. The small side of our 30, 60, 90 triangle on the unit circle is 1/2, and our long side is square root of 3 over 2. Secant is the reciprocal of cosine. On the unit circle, cosine is the x value. So secant is going to be 1 over the x value. Now, I do want to point out that we are in quadrant 2, so our x value is negative while our y value is positive. We want 1 over the x value. So that's 1 over negative 1/2, which simplifies to negative 2. To simplify that, we can either think of, well, just what's the reciprocal of negative 1/2, negative 2, or we could have switched this to multiplying by the reciprocal of the second fraction. Either way, we get secant of 2 pi over 3 to be negative 2. Next, we want to find cosine of negative 5 pi over 6. I'll start by converting this to degrees. multiplying by 180 over pi. It's going to be negative 150 degrees. Since our angle measure is negative, we're going to be going in a clockwise rotation from our positive x-axis. So negative 50 is going to be here. We're going to drop a perpendicular to the x-axis, creating a right triangle, and then we want to find the reference angle. We're only 30 degrees shy of 180, so that's got to be the 30-degree angle. This has to be the 60-degree angle. In a 30, 60, 90 triangle, the short side across from the 30 degrees is 1/2, and the long side is square root of 3 over 2. We are in quadrant 3, so both the x and the y value are negative. Cosine on the unit circle is our x value. So there's our x value. This is going to be negative square root of 3 over 2. So I want to point out like a little shortcut that we can use to help us with the radian that might skip us having to actually convert it to degrees. I'm just going to point out a pattern. Every time the denominator of our radian is 4, it's going to be a 45-degree reference angle. Every time the denominator of our radian is 3, it's going to be a 60-degree reference angle. And every time the denominator of our radian is 6, it's going to be a 30-degree reference angle. I keep that in mind, and then I don't have to do all that conversion. We'll do a few more, and I'll show you how we use that as we go. To help us remember which one's which, I don't know, the 4 and the 45, I put the 4's together, and these two I just remember are opposite. When I see the 3 in the denominator, it's got to be the 6 with the reference angle, and when I see the 6 in the denominator, it's got to be the 3 for the reference angle. But you can always just convert it to degrees as well. Next up, tangent of 4 pi over 3. So right away I look at this, I see the 3, and that tells me I have a 60-degree reference angle. I just need to figure out which quadrant I'm in. Well, if we label in degrees, this is 0, 90, 180, 270, and then back to 360 degrees. But if we label these same angles in radian, we get 0, pi over 2, pi, 3 pi over 2, and then back here to 2 pi. So what you can do is you can look at your radian measure like without the pi. Just look at 4/3. And that we have 4/3 pi. Well, 4/3 is bigger than 1, but less than 1.5. Well, this is 1 pi, and this is 3/2 of a pi, 1.5 pi. 4/3 is between 1 and 3/2, so I know that my angle is going to fall in quadrant 3 and have a 60-degree reference angle. Got my 60-degree reference angle. I know that square root of 3 over 2 is across from that 60-degree reference angle, and then 1/2 is across from my 30-degree reference angle. Since we're in quadrant 3, both the x and the y value are negative. And then I need tangent. Tangent is y over x. So I'm going to take my y value, negative square root of 3 over 2, and divide it by my x value, negative 1/2. Now a negative divided by a negative is a positive, so I know this is going to be positive. I'm not going to think of the signs anymore. But to simplify this, I'm going to multiply by the reciprocal of the second fraction. We get the tangent of 4 pi over 3 is equal to the square root of 3. Next, we'll find cosecant of 3 pi over 2. Well, you'll notice that this denominator is not a 3, 4, or a 6. So that tells me right away I'm not even going to use one of my special right triangles. 3 pi over 2 falls on one of our axes. If we converted this to degrees, we get 270 degrees. So that falls right here on our negative y-axis. So when that happens, we don't use our special right triangles. We just choose a point, and since we're on the unit circle, that point is going to be 0, 1. Cosecant is the, it's going to be 0, negative 1. Cosecant is the reciprocal of sine, which is y, so cosecant of 3 pi over 2 is going to be 1 over the y value. So that's 1 over negative 1, which is negative 1. Let's find cotangent of 7 pi over 4. I see that denominator of 4 in my radian, and right away that tells me I have a 45-degree reference angle. I just need to figure out which quadrant it's in. So I look at just, the coefficients, 7 over 4. Now, 7 over 4 is more than 3 over 2, but less than 2. So I know that this angle is going to be in our fourth quadrant with a 45-degree reference angle. Again, if you're not comfortable with that, you can just convert it into degrees and then still know that it's a 45-degree reference angle based on the denominator. So 45-degree reference angle. I know on that one, both sides are square root of 2 over 2. Since we are in quadrant 4, our y value is going to be negative. And now I need cotangent. Cotangent, which is the reciprocal of tangent, is x over y. So I'm going to take my x value, positive square root of 2 over 2, and divide it by our y value, which is negative square root of 2 over 2. A positive divided by a negative is going to be a negative, so I already have it in mind that my answer is going to be negative. So I'll just write that, and then to simplify it, I'm going to multiply by the reciprocal of the second fraction. Notice that everything cross cancels out. This simplifies to be just -1. So, like I said, it is super important that we're able to quickly find these values. I can't say that I didn't just memorize the unit circle when I was a student. And here is a picture of a fully filled out unit circle. I can't say that I didn't just memorize this as a student, but for long-term memory, understanding those two special right triangles and knowing how to inscribe them is really, really important. I do have a nice color-coded unit circle posted in D2L for you to print out as well to use as reference, but again, understanding how the triangles inscribe in it is really best for long-term memory.